Okay, Ethan. I'm up here working, and I've gotten hungry, so I may be talking with my mouth full every once in a while. All right, 2-4. We've got some definitions. So, and you know what these are, but here's the formal definitions. So, complementary angles are two angles. It has to be just two. It can't be three that add up. So, two angles whose measures, because you can't add angles, you can only add the measures of angles, add up to 90 degrees. Supplementary angles, two angles whose measures add up to 180 degrees. And vertical angles are two angles whose sides are opposite rays of each other. Whoops, what's that supposed to be? Opposite rays of each other. Okay. So here's some drawings. Sketch the following. Again, I'm going to freehand it because I'm doing the iPad, but if I were to do this for real, hang on. I do just straight edge. Okay, first we need adjacent angles. So remember, we need four things to happen. They have to be coplanar, have the same vertex, share a side, and share no common interior points. They're going to be non-congruent and complementary. So we can't draw 45-degree angles because that way they're not congruent. So if I want to say we've got a big right angle, and maybe this one's 10 degrees. Let's do 20 degrees. And this one's 70 degrees. Then those two angles, this one and this one, are complementary because their measures add up to 90 degrees. They are non-congruent because their measures are not the same, and they are adjacent because they're in the same plane. They share that vertex. They share a single side, but they share no interior points. Okay, this one, again, we need adjacent angles again. We need them to be complementary, and we need them to be congruent. So I kind of hinted at what's going to happen there. This has to be a 45-degree angle, and this has to be a 45-degree angle. That takes care of that. Okay. Next one. We want complementary, non-congruent, non-adjacent angles. So we've got a lot going on. We've got to be non-adjacent. So we're going to put them beside each other. We want them to be complementary, so we want their measures to add up 90 degrees, but we do not need them both to be 45 degrees. So it'd be something like maybe you've got angle A over here, and that's a 30-degree angle. And then somewhere else sits angle B, and it's 60 degrees. All right. Supplementary, congruent, adjacent angles. So we're going to be adjacent, they're going to be congruent, and they're supplementary. Well, the only way they're going to be supplementary, their measures have to add up to 180 degrees, and be congruent is if they're each 90 degrees. So that would be like this. Those two angles are supplementary, congruent, adjacent angles. Supplementary, non-congruent adjacent angles would look something like that, where this is one measure and this is something else. And they're not both right angles. Supplementary, congruent, non-adjacent angles. Well, if they're supplementary congruent, they both have to be right angles. So say there's an angle A here, and then some random place it's an angle B, but they're both right angles. All right, just vertical angles. So, oh, darn it. I've got this on the wrong page. I need to, if I remember, when I get done, I'll go back and reprint this for you and get this off the bottom of this page and at the top of the next one. So, angles 1 and 2, those are verticals. We'll say we do angle 1, 2. Why did I say 1 and 2 before I labeled them? Let's say this is 1, 2, 3, and 4. So Angle 1 and angle 3 are vertical angles because they're two angles whose sides are opposite rays of each other. Same goes with angles 2 and 4. Now, I've got them marked as being congruent because I know that, but not because of the definition of vertical angles. The definition of vertical angles is just how do we recognize one? To know they're congruent, it's a theorem that we proved where vertical angles are congruent. Okay, so we're going to complete each statement below using always, sometimes, or never. Two right angles are, so they're both right angles. Two of them, there's no way they're going to add up to 90 degrees, are never complementary. However, they would always be supplementary. Right angles are sometimes vertical angles. You know, if you've got those two, but if you have those, go back. You have these two, not so much. All right, angles A, B, and C. Oh, never. 1, 2, 3. Three angles aren't ever going to be used with the words complementary, supplementary, so just two. And then vertical angles always have a common vertex because that's how you draw them. Okay. Define your variables, write your answer in complete sentences. We're going to work these problems. So, number 15. Hang on, I got to get some tea. I'm really hungry. I'm also really tired. I'm ready to go home and go to bed. And it's only 5:28, so that's pretty bad. All right. The measure of one of two supplementary angles is 4 times the other. Find the measure of the larger angle. So let's say A is the measure of an angle. So its supplement is whatever we add to that to make 180. So its supplement is going to be 180 minus A. So this is the supplement of A. All right. So the measure of one is 4 times the other. So the measure of one angle is 4 times as big as its supplement. So let's just distribute. That's going to be what, 720 minus 4A. We'll add 4A to both sides. We'll divide both sides by 5, 144. So one angle is 144 degrees big. Its supplement, therefore, is what, 36 degrees? So that's our two supplementary angles. And then find the measure of the larger angle. The measure of the larger one is definitely the 144 degrees. But I didn't know which one was going to be larger going in. All right, so this one of two complementary angles has a measure that's 20 degrees larger than the other. So let's say A is the measure of an angle. So its complement would be 90 minus A. So that's its complement. So complement of A. So one of those complementary angles, let's call it A, has a measure that's 20 degrees more than the other one, which would be this. So that gets me to here. I'll add A to both sides. I'll divide both sides by 2. So one of my angles is 55 degrees. Its complement is 35 degrees. Find the measure of each. So the measures of the angles are 55 degrees and 35 degrees. Okay. All right, next up, the measure of the supplement of an angle exceeds 3 times the measure of the complement of the angle by 10 degrees. So let's say A is just the measure of the angle. So if we want its complement, that's going to be 90 minus A. And it's 90 degrees minus A. I'm just going to put 90 minus A while I'm writing it down. Well, I guess I should put that in. Its supplement is going to be 180 minus that angle. So the measure of the supplement exceeds, so it is 3 times as much so it exceeds it by 10. So this is 10 more than 3 times the complement. So, oops, that looks weird. 270 minus 3a, add another 10. Let's add 3a to both sides. So we've got that. If we subtract 180 from both sides, that'll leave 90, and then you still have that extra 10. So the angle itself, 50 degrees, okay? That makes its complement 40 degrees, which would make, remember this is the angle, which would make its supplement 130 degrees, but what do they want to know? Find the measure of the complement. So the measure of the complement is 40 degrees. And I know I'm flying through this, but just like always, I know you can pause and try everything on your own, which is what you should be doing. I kind of assume you are, and maybe I shouldn't assume that, but I want you to try these on your own before you just write down what I'm doing. So if 3 times the measure of the supplement of an angle is subtracted from 7 times the measure of the complement of the angle is the same, the answer is the same as the measure obtained by trisecting a right angle's measure. Find the measure of the supplement. Okay, so let's say A is the angle. Let's do complement's 90 minus A. Supplement's going to be 180 minus A. So if 3 times the supplement is oops, hang on, I need to give myself more room. If 3 times the supplement is subtracted away from 7 times the complement, it's the same measure as trisecting a right angle's measure. So cutting a right angle into thirds, which would be 30 degrees. So let's see. Well, I guess we should probably, since it's your note, let's write that we're doing 90 divided by 3. Okay, so here's what, 630 minus 7a minus, let's see, 540 plus, ooh, that looks weird. Let's fix that. Plus 3a is 30. Let's see, so put all these a's, negative 7 plus 3, so it's negative 4a. 630 minus 40, that's 30 and 60 more. That's 90. So I'm going to bring my 4a over here, subtract 30 from both sides. So a's got to be half that's 30. It's going to be 50. Okay, what do they want to know? Find the measure of the supplement. So if the angle itself is 15 degrees, then its supplement is 165 degrees. So the measure of the supplement is 165 degrees. All right, let's see. The ratio of the measure of an angle to its supplement. Okay, so A is the angle. Its supplement is going to be 180 minus A. A ratio is just a fraction. So the measure of the angle to its supplement is 3 to 7. So I'm going to cross multiply. So 540 minus 3a, we'll add 3a to both sides. Divide both sides by 10. So the angle's measure is 54 degrees. Find the ratio of the measure of the angle to the measure of the complement. So the angle itself is 54 degrees. Its complement then is what, 36 degrees? So we want the measure of the angle to the measure of the complement. So let's half both of those. Let's divide each of these by 9. And we could divide the degree signs off both sides and just get it's a 3 to 2 ratio. So the ratio of the measure of the angle to the measure, that looks awful. Ugh. of its complement is 3 to 2. And think of it this way about why did the degrees go away? Because if it were 54 degrees divided by 36 degrees, the degrees just cancel out. Okay, all right, we got that. Well. Oh, good. We're almost done. Okay. So we have this diagram. It's not a proof. It doesn't say proof, so we do not need your 2 columns. It's just another way of setting it up. So measure angle 1 is y squared plus 2y degrees. Angle 2 is 20y plus 12 degrees. This one's 3y plus 4x degrees. All right, so I'm going to set up a system because here's the 2 things I know. I know that angle 1 and 2 are a linear pair, which is going to make their measures add up to 180 degrees. So there's one thing I know. I know angles 2 and 3 are the same thing. So I know that 20y plus 12 added to 3y plus 4x also has to equal 180. So let's clean up what we've got right here. That's going to give us that y squared plus 22y minus what that's going to be, 168. It's going to be 0. And then this one down here, I've got 23y plus 4x. And actually, I know it's silly. I know it's the same thing, but I just like the x before the y on that one. Equals, subtract 12, equals 168 degrees. Okay, so we're definitely going to work with this one. You know what? I'm going to complete the square. Because half of 22 is 11, square that's 121. I can just add 121 to both sides. So, let's see. This is a y plus 11 all squared. There's 289. So that y plus 11 has to either be positive or negative 17. So negative 11 plus or minus 17. So if I do negative 11 plus 17, that's 6. Negative 11 minus 17 is what? Negative 28. All right, let's see. If I put a negative 28 right here, 20 times negative 28 is pretty far down the negative side. Add 12 to it, so I'm going to throw that one out based on the measure of angle 2. Let's see, will 6 work? 6 squared plus 2 times 6, that's positive. 20 times 6 plus 12, that's positive. So far, y equals 6 is looking okay. And then I can come to here then, and 4x plus 23 times y is 168. 18, carry the 1, so there's 138. We'll subtract 138 from both sides, divide both sides. That's 15 over 2. It's just 15 over 2. And what do they want to know? Find x. And let's just make sure that if we put that there, will it be a positive number? It sure will. So x has to be, therefore, x is 7.5. All righty.